Hello everyone. In the last video I talked about the generic class and I was dealing with the inbuilt generic class ArrayList. Okay. Now in this video I'm going to talk about how to create your own generic class, custom generic class. Okay. But before I start with that, you need to understand this thing. The generic classes do not work with primitive data types like byte, short, int, which you already know. Okay. So we have to use their corresponding classes. These are called wrapper classes. Okay. For corresponding byte, I have byte class. For corresponding short, I have short class. For int, I have integer class. For long, I have long class. Similarly, for character, I have character class. Char, I have character class. Float, for float, I have float class. Double class, and boolean class. So only thing you have to remember is for char, I have character. For int, I have integer. Rest the names are same with the first letter capital. So these are the wrapper classes. So the classes corresponding to the primitive data types are the wrapper classes. Okay, and I'm going to use them inside my demonstration program. That's why I'm giving you a brief introduction. Now let's look at some of the methods inside the wrapper classes. We have integer class, byte class, short class. Overall we have 8 wrapper classes here. Okay, and some of the methods I'm showing you here. Let's say I'm using an integer class. Okay, integer class object. So in order to fetch a value from it, from the integer object I could fetch int value by using this function. I could fetch double value by using this double value method. If you want to fetch the float value, you can use this method. Okay, and then you could fetch the byte value also from it. Int was also already mentioned. The byte value, long value, or the short value. Similarly, if you are dealing with a byte class, you can fetch any kind of value from it. Short, you can fetch any kind of value from that object. For long, you can fetch any kind of primitive value from it. Okay, remember you cannot just fetch the character value. There is no char value function. Okay, so from the character object you can only fetch char value and not any other value, primitive value. For float you can fetch all the primitive types except the char. Again, from the double you can fetch all the primitive types except the char, and from the boolean you can extract only the boolean value. Okay, so these methods I'm going to use inside my example program in order to fetch the primitive values from a particular object. So let's first of all see the code here. This is a non-generic class I'm making. Okay, class gen. Inside that I have an instance variable and there is a method which sets its value, a setter method and a getter method to fetch that value. Okay, setter and getter methods, I hope you know about them. Okay, and now since this is a non-generic class, it works only on integer values. I'm taking a very short example here. Okay, what if I want to work with a double data type also? Then what I have to do is I have to make a separate class. Copy this code, paste it here, and let's say its name is gen2, and I have to just change the data types, double value, and it will return the double value. Okay, similarly, what if you want to work with the same code but the data type should be of type float, or the data type should be of let's say char. Okay, or if you want to work with the strings, then you have to write all those classes separately. Okay, so this is a big hassle. So in order to remove this hassle, can we not do that? We make just one class and that will be automatically converted into one specific type by the compiler. There comes the generics. Okay, let's see this. Instead of making the separate classes, now see this carefully. I make a generic class. First of all, what you have to do here, let's say all the integers I'm going to convert them into, wherever I have written int, I'm going to convert them into some parameter. Okay, a variable. Okay, so first of all you have to declare at the header of the class that I'm creating a class which should work on type T. You can write anything here, E, F, G, but normally we just write it as T here. That's just a convention. Okay, we write T here. You can write anything else also, like temp and so on, but preferably it should be just one capitalized. You can use small characters also, but the T is preferable because I'm making a sort of a template. So that's why the Java, I guess, because I've seen this thing written in the books and everywhere, so they're generally using the T, capitalized T. Okay, so wherever I have written these specific data types, convert it into T, convert into T, convert it into T. Okay, so this is how I created a generic class. Now at the time of making an object, gen, how will I make the object? Gen of type, let's say integer. Obj is equal to new gen of type integer, right? So this corresponding class, wherever I have mentioned T, it'll be replaced by integer. Okay, so if I'm specifying here, let's say gen of type, let's say now string. Okay, obj2 is equal to new gen of type string. Okay, now compiler will make a separate class of this one of type string. Okay, let's try to understand this in this particular code. If I'm making this one generic class, so when I write here gen of type integer, obj is equal to new gen of type integer, compiler will convert this class into gen of type integer. Okay, so wherever it was written T, so it will be converting into gen of type integer. So if I write gen of type string, so compiler will make another class at the background, like, let me complete the code. Compiler will create another class at the background of types of, let's say I take double here, double. So compiler will automatically create another class of type double. So I do not have to create my own classes separately, the compiler will do it for me. Okay, similarly if you mention the third data type, then the compiler will automatically create the third class for you, and wherever you have written the parameter, that parameter will be converted into a type. So wherever you have written T, so you mention that T value at the time of making the object. Okay, so if you mention integer, T got replaced with integer. So if you have mentioned double, so T got replaced with the double, and so on. Okay, so this is the advantage of generics. I just have to write once the class, and that could be work, and I can make the class work with the any data type. Okay, but remember, not the primitive types, only the class types. Okay, now coming back to the code where I have written this gen integer of type obj is equal to new of integer. So what I do is, let's set the value obj dot set method, provide the integer value, new integer of type 23. Okay, I've used the set method. Now I can use the get method, integer I is equal to obj dot get will return me the object in I. Okay, and then I can print it, system dot out dot println I dot int value, fetch the integer value from it. Okay, so 23 got printed. You can do this thing also, just for your information. You could just type I also, and compiler will automatically fetch the integer value from it and print it. So this concept is called auto unboxing. Okay, but I give you the full demonstration. I mean, try to write the complete syntax for your knowledge. Fetch the integer value of it. Similarly, you're dealing with string here. Okay, the same line of code will go almost. Copy it, paste it here, and instead of obj2.set, remember string is not a primitive type. Okay, string is a class in itself. So string s is equal to obj.get and s. I just print s here. obj2.get, sorry. Okay, so try to run this code now. 23 and hello. Okay, so now you'll be able to understand this code also, example program, almost same to that. Okay, this one is same. Okay, now instead of string I'm just taking the double data type, double class. Okay, feel free to pause the video, and they almost work the same way, right? Now let's try to see almost the same code here, but this one is trivial one. If you try to do this is just for the sake of your knowledge. If you try to see this code, I'm making a reference variable of non-generic type. Okay, I'm not specifying type here. So by default this gen will be of type object, gen of type object, and here you make the gen of type integer. Now have a look at the note here. This node is specifically for this one. Okay, type of values, that is the objects stored in a generic class, depends upon the type of its reference variable. Okay, type of its reference variable. So the reference variable you just created is of type object class. You don't specify the type here, so compiler will treat it as gen of type object. So t will be of type object in this case. So it doesn't matter what you write here, integer, float, or whatever. Okay, you can store any kind of object into it. So let's say I just write obj1.set23. okay, remember I'm not adding primitive value inside it, I'm actually storing the integer object. Compiler will automatically convert this syntax into new integer of 23. Okay, then while fetching I have to downcast it. Okay, because this was made gen of type object. Okay, so obj1.get will return me the object type. So all the t's which I have mentioned here got converted into object class. So get method will return you t. T means the object. So object has to be downcasted to string and has to be stored inside the string variable. Okay, similarly but wait a second, I just stored in my previous line integer and I'm downcasting it wrongly, so this will give you a runtime error as mentioned here. Okay, so you did the wrong downcasting here and that will give you runtime error. But the next line, if you comment this line here, okay, comment this line and this will work fine. This was the actual line you had to write. Means that's the disadvantage of non-generic. If you do not specify anything here, that is by default an object class, generic of object class. Okay, and similarly you can see the rest of the code also. obj1.set hello. Okay, you can write add any other kind of object also into it. And now if you're writing this thing, you're downcasting it right, fine. But if you use the next line, this is a runtime error, because now the thing which you're fetching from here is actually a string variable now. Okay, not an integer variable. So this will give you a runtime error. So don't be confused here. Earlier I stored in this a variable 23. Okay, after that in the same variable I stored the hello. Okay, so that the value got overwritten here. That's why the second line will give me a runtime error now, because integer got overwritten with a string object. Okay, sort of you can say not overwritten, but I would say it is referring to pointing to different object now. So feel free to pause the video and have a look at this node once again. The type of values, that is the object stored in a generic class, depends upon the type of the reference variable you created here. Okay, and in other words, it does not depend upon the type you specify while creating the object. Means this doesn't matter here. But one thing you have to be sure, but make sure that the type you specify with the object, means here, must be compatible with the reference variable type. Okay, so reference variable here was by default of type object, and integer is the subclass of objects. That's why it was compatible. Okay, so you try to write here gen of string obj1 is equal to new gen of integer, and both of them are not compatible with each other. Okay, so that's the main point here. Okay, that was the main point about the generic class which I created it myself. In the next class, in the next video actually, I'll just tell you about how to create the generic class of multiple types. Okay, because you might have more than one type here. It could be something like integer here, and somewhere it could be float here. So means multiple types, how you deal with them. Okay, so watch out for my next video.